anyone listening who now is more confused, the good news is it's given me a new topic for my next Tech Talk Simplified, neural networks. Here it comes. Welcome to Tech Talk Discussed. I'm Wally Gustafson. I lead the innovation team at Reese USA. Today is our first ever Tech Talk Discussed. So just like when we build tools on our innovation team, today is sort of the proof of concept for this format and our Tech Talk series. So no pressure on our guest today, but a lot of this rides on your performance. Our topic today is natural language processing. So before we get started, let me introduce you to our guest. From the Reese Innovation Team, David Wise. David's a business analyst and project lead on the innovation team. He also hosts other tech talks, so be sure to check out his videos. And then while being very smart, David lives 30 miles away from the office and still regularly seems genuinely surprised by how long it takes to get to work. So David, thanks for joining us. Appreciate it.
Glad I could make it in.
And then our special guest today come to us from Austin Artificial Intelligence. Austin AI, as I'll refer to him a lot, is a key partner for the Reese Innovation Team. Really enjoyed working with everyone at Austin AI. So first up is Rob Corwin. Rob is the founder and CEO of Austin AI. In addition to his time at Austin AI, Rob spent years in quantitative research and running a hedge fund, to name just a few. And when he's not at work, you can almost assuredly find Rob on his hydrofoil on a lake in Austin, Texas. Rob, thanks so much for joining us. Appreciate it.
Thanks for having me, Wally.
Last but definitely not least is Kahlil Wehmeyer. Kahlil is a senior data scientist for Austin AI and essentially manages all the Austin AI resources on Reese Austin AI projects. So it puts him in like this unusual relationship where Kahlil works for Rob, but because Rob gave Kahlil the role to manage Austin AI resources, often Rob ends up reporting to Kahlil. And then while growing up in South Africa, Kahlil recently became a U.S. citizen. So congrats on that. Kahlil, thanks for joining us. Appreciate it.
Yep. Thanks, Wally. Happy to be here.
Just a reminder that the goal of Innovation Tech Talks is to make complex technologies, particularly those around artificial intelligence, easy or at least easier to understand. So some of what we discussed today might get a little technical, but we're going to really do our best to eventually land on some common sense explanations and use cases. And I thought the first place to start is just to talk about NLP, or natural language processing, just in general. So outside of projects that we've worked on here at Reese. And I was wondering, Rob, maybe you could just get us started by telling us a little bit about your past with NLP and maybe some projects where you've employed this technology.
Sure, I'd be happy to, Wally. So at Austin AI, we've done several projects with several clients using NLP. Everything from simpler things like user reviews for a construction payments company, judging the sentiment and quality of those reviews, to analyzing sales calls. So we did a project where we actually took a transcript of someone attempting to sell something to somebody else, analyzed both speakers and their intent, their emotion, and some other statistics surrounding that. So that was a very interesting project. We've also done a lot of scraping of social media and other types of sites, such as YouTube, whereby we pull down content, either video or audio, and analyze that content for what's being talked about, such as brands or companies or stock tickers, in the manner in which they're being talked about, namely positive or negative. So those are a few of the examples of some of the things we've done. I would say the common thread between all those is that there's really a high degree of customization needed to make these things work well. It is pretty easy in this day and age to download a sentiment model. With a click of a button, you can do that. The problem is that it often misses the nuances of a particular business, circumstance, or vocabulary, something like that. So a lot of what we do at Austin AI is helping clients customize these models. We may take an off-the-shelf model, such as Google BERT, which is, I think, a best-in-breed NLP transformer-based model right now. In the case of the financial one, we found a professor who had retrained that thing on finance. So we used that, and then we further customized it using our own knowledge. So, for example, the word sell short may mean something completely different in a financial context than in everyday conversation. So we had a lot of customization, implementation, and production on top of these models.
When you talk about sentiment analysis, what are some of the biggest challenges you found when it comes to working with that?
Yeah, I was just going to say negation, which is a similar, I think, to what you're saying. The word "not" can drastically alter the meaning of a sentence, especially if it appears in, say, a very different place in the sentence as what it's referring to, so that you can construct a sentence where, I don't think appears, and then there's a huge sentence after that. So I'd say the off-the-shelf models right now that just focus on sentiment tend to have a difficult time with that. Certainly some of I think the newer large language models seem to be very good at handling that. But at least up until very recently, nuances like stop words, negation in particular, subtleties in how people speak. So they may say that, I think that instead of I know that, or things that a human would pick up on that a computer would not. And then it's really, again, the industry specific vocabulary. So, finance sells short, in construction, perhaps lean, L-I-E-N, has extremely negative connotation, because liens are what people put on you as a contractor when you're not paying them. They can sue you for your property. So that is a very particularly negative word. And I'm not, let's see what the plumbing equivalent would be, but perhaps
yeah, I don't have to think about that
burst
one.
Pipe.
Burst, burst.
Yeah.
Leak is probably a hugely negative.
Yep.
What about leak proof, right? Those are, there you go.
Yeah, exactly.
Separate. I had a similar project that I worked on a couple of years back in 2019, and the goal of the project was to do sentiment analysis on political figures in the 2020 election, and to figure out if if people are agreeing with these political figures or disagreeing, and what's the general public sentiment. Now, obviously, Twitter tends to lean one way or the other as a whole, but it's very interesting, because what I had found when working on that project is that context was very important. I could look at something that some presidential candidate had tweeted, and they might say something like, "This is great," right? And if you just do sentiment analysis on that sentence, it's like, okay, they're saying something positive. They're a very upbeat person, but maybe they're replying to a tweet about something really horrible happening to another candidate. So that's where, like Rob was mentioning, some of these larger models, like the long-term, short-term memory models and transformers, really have been pushing the field forward, because they also account for context, which is very important.
Let me ask you this, Kahlil. Excuse me. How do you see NLP changing or maturing over time?
I think it's very easy to talk about the different use cases for NLP, but when it comes to the underlying technologies that get developed, it's a little bit more nuanced. Lots of different fields in machine learning and AI don't always share techniques and research, but I think for NLP specifically, transfer learning is something that I hope to see more productionized in the future. For example, you could have 5 PhDs working on an image recognition model that can predict a cancer cell out of healthy cells 99% of the time. But do you have to do that exact same thing for sickle cells? Not necessarily. You could use transfer learning to basically build off of what you've already done. And I think, when you look at lots of these like cutting edge chat generation and NLP models, they're trained on massive swaths of data, but they're kind of like a jack of all trades, master of none. And I think transfer learning, specifically into like very precise and niche domains of those models, will make it more applicable to a wider range of business use cases, rather than just, oh, I can ask this thing a question, it's going to tell me something funny. So my hope is that transfer learning and like current transformer-based technologies kind of come together, so that you do end up with very precise and specific models for specific domains.
Yeah, I think something that you pointed out there, the jack of all trades, master of none, even when you're looking at some of the tools that are available nowadays, and the ability for them to maybe even analyze code at some level, right? Or write code. Most of the time in a lot of those scenarios, it's okay, right? The code is okay, but it's not like the best code. It's not the best way it could be written, as it's just a version of saying that it can do it. And so being able to then go in and specialize in a niche way, whether it's us in our industry of providing these wholesale products, or whether it's in the industry you guys are in, where you're specifically focused on writing code for specific tools, finding the niche and being able to fine tune is super exciting.
Yeah, I would just add, it seems the days of opening, TensorFlow and making it a neural network from one of their generic templates, and then training it on a task with no other outside input are coming to an end, or at least shortened success, because I think people are now building upon each other's models, as Kahlil said, but also architectures. Right? Architectures are getting increasingly complex, and it's very common now to see papers come out that reference an architecture someone else made and then make a tweak to it. So it seems that knowledge is really compounding at this point and building upon itself, and models are as well. So yeah, I think we would expect the best performing models going forward to be pretty complex in architecture and in the training that it underwent. Bear in mind, like GPT, for example, it costs like $1 billion to train or something ridiculous like that. So, to my understanding, so yeah, I think there's going to be a lot of compound knowledge being built up for incremental models and improvements at this point.
So I'm going to put you on the spot here. You mentioned neural networks. For anyone listening to this who's like, I don't know what that is, can you tell us what a neural network is in sort of a simplified manner?
Sure. A neural network is a non-parametric algorithmic way of estimating parameter, or maybe that's too technical, but it's a model at the end of the day.
It sounds more technical now, so you're gonna have to explain that.
It's a form of model to getting to the estimate of something you're trying to estimate, whether that's a prediction or a value you're trying to estimate. But the structure of it is very different than, say, a parametric equation like a regression, right? Which is you're trying to solve an equation to get a specific mathematical answer. These things are very nonlinear, and basically they're composed of nodes which are meant to simulate neurons, right? So you have one layer, which is the input nodes, and each of these nodes might be a specific factor or variable, right? So it might be the weather and the time and sales of the last quarter, or the stock market level, something like that. And then the end level is something you're trying to predict, and you can be trying to predict one thing, so that end level might have one set of nodes, or it might have 20. It might be a category you're trying to predict, or a number, or a word, as in the case of NLP. And in between these two things are a bunch of interconnected other nodes. So it's supposed to represent a brain in some sense, right? The start nodes feed the middle nodes, which feed the end node. And lots of things are interconnected, and sometimes in a very complicated way, where you now have things referencing, whole little other modules of neural net, mini neural nets, and also past information. So information, lagged information or contextual information. So think of it as a giant, interconnected set of nodes. And the way you train these things is you start at the end actually, and you figure out how to minimize the error or some kind of loss function across all the different weights. You keep adjusting the weights. You can look at, there are various ways to do this, but you can look at the derivative of the error function with regard to the weights, and you keep adjusting the weights on all these things. So at the end of the day, these nodes have different weights. And so we might find that the weather node has a really big weight, but that the day of the week node has a very low weight, right? And so but they are, they're a black box. that sounds like a very black box thing, and they are, right? It's sometimes very difficult to interpret at the end of the model which factors really do matter. So that differs from parametric, more explainable types of models. And for a while, these things were they were invented many years ago, ignored for probably 2 decades in the 80s and 90s, I guess, because people were not getting very good results out of them. And really, over the past two decades, several things have happened that have just increased their popularity. One of which is most certainly, the abundance of computing power. You no longer need to buy big servers to do this. You can click a button in AWS and have a super powerful server that can estimate, the parameters of the neural net. So that's certainly part of it. And then really also architectures have just gotten much more complex. So, one neural net in and of itself is, it might be okay, but now you're using incredibly complex architectures, combining these things with reinforcement learning and other types of things. And they're proving extremely successful at the moment.
Awesome. And for anyone listening who now is more confused, the good news is it's given me a new topic for my next Tech Talk Simplified, neural networks. Here it comes. Thank you, though. I really appreciate that explanation. So I think this will bring us, I think now's a good time to segue into a project that we partnered with you on, which is a project we called PoST. And it was a very direct title just because it's parts of speech tagging. And it was built to be a search service for Reese. So really a standalone service that could be plugged into by anyone in the organization for multiple uses. But initially, it was designed to act as either an alternative to or a supplement to our existing e-commerce search tool. And then now PoST is going to play a big role in two additional tools that the innovation team is building. And that's one is an AI chatbot and the other is an image recognition tool. Now, we took a pretty unique approach to parts of speech by creating our own. So I was wondering, maybe one of you want to talk about, hey, what are traditionally parts of speech? And then what did we have to do to create Reese parts of speech?
So the PoST project is in the vein of, I suppose, what is usually called named entity recognition, or perhaps parts of speech analysis. And the idea is to identify and then categorize each distinct phrase or word as something. So off-the-shelf named entity recognition models usually will return things like a country. So it knows that United States of America, states does not actually mean a state, but it's part of a country. And so that's useful when you're doing NLP because you need to know that that thing is an entity. They also typically recognize people, if it says Steve Jobs, and also like currency amounts are, let's say, the most common things that these things recognize. Like many off-the-shelf machine learning models, these things don't really have any idea what anything, for example, in plumbing is, or industry-specific types of terms. And so the goal of this project was really to see if we could do that for plumbing-specific terms. So now we know, as you know, what a part is, a pipe, and it knows what the temperature is, 100 degrees Fahrenheit, and it knows what a manufacturer is, so it knows what Kohler Company is. Why is this information important? This is important because once we identify these things in either a search query or in the product catalog, we can match them up. We can, the big ability that it gives you is the ability to not do a string search. If you're just searching for the word, say, pipe in the product catalog, you might come up with Acme Pipe Company, or you might come up with 2-inch copper pipe, right?
Or pipe straps.
Or pipe straps, yeah.
All across the board.
Exactly. And so I think when we sat down and thought about this problem, we realized pretty quickly, without that ability, we're going to be back to square one with search, right? Just there's plenty of search specific things that are out there, search technologies, ways to find the best records and the most relevant records. But really, those things were not granular enough, right? We felt that this was the proper way, that in the long run, this would provide the best results. And so, it's basically a glorified named entity recognition part of speech tagger. And it's been very exciting to teach the computer, what dimensions are, like 2 by 4 feet or something like that. So.
No, it just kind of goes back to what I said about transfer learning. Off the shelf named entity recognition models, they're always trained on massive academic data sets of publicly available information. But I doubt a company like Reese is sharing their machine learning models with their competitors. and they're domain-specific lexicons with other people. So it is necessary to go down to that level and teach something custom about use case specific parts of speech. Lots of the kind of the introductory models, when you first start going into NLP, you can give it a sentence and it'll tell you, pretty is an adjective. And it's like, okay, great. I know it's an adjective, but what do I do with that information? And there's definitely use cases for that stuff. But when talking about PoST specifically, a part could be an adjective, or like a word like pipe could be an adjective for a tool, right? Like a tool like a pipe cutter, right? The tool itself is a cutter, but what is it cutting,
So I mean that actually leads into my next question here, and maybe you could just start off, Kahlil. Like, what was harder on this project than maybe you originally anticipated or thought it would be?
It's just the variation of, and just like the variability of the data that we see. Iterating over not only the product catalog, well, mainly just the product catalog. Lots of the products in the product catalog have different formats, and there's not like and this is part of the reason why we went on this PoST endeavor. There isn't any easy win, and you just have to kind of sit down and be like, okay, I'm gonna come up with the parts of speech, come up with a linguistic model for a product catalog, and it's going to be a big pain, but I'm going to do it one time. And then, after that, no further work is required other than training and tuning.
100%. And I think that attitude is the attitude that I know that you've heard it before. My team has heard it so many times. It's like, we're not waiting for someone else to do something for us, and it's never not our job. So was it fun? Nope, it was not fun. Was it hard? Yes. But it's just like what you have to do to get to the end goal. And I do think that sometimes that can happen in siloed organizations where there's very clearly defined roles. And Reese really does a good job of trying to not be siloed. But inevitably what happens from time to time is there's a person who goes, no, I manage this particular area. And so you often find that you defer to those individuals. And whether for good or bad, we decided we're not going to defer. We're just going to say we're going to do it because we're pretty confident that in the end, people will be happy that we did it. And there'll be other use cases for that. Rob, anything that Kahlil didn't mention that maybe you thought was harder than you originally anticipated?
I think in the same vein, the quality of the product records, so as you know, sometimes it's good and sometimes it's very poor. So sometimes you get a full product description, and then sometimes you get 10 words that have been abbreviated, and that's it. So despite the part of speech tagger, this still presents a lot of problems that we've are increasingly working to overcome. We've overcome those by doing things like implementing probability-based scoring for parts and some other techniques. But again, those only would have been possible had we had the parts in the first place. So just really feeling good about the choice of that, right? I mean, there were really, when we sat down for this, there was a choice to do that and a choice to not. And if we didn't do this, we could have progressed on the search part of it, faster. But what we would be doing is working on search algorithms to boost a certain field and to penalize something else, and to find synonyms in some other manner, and then hope that you don't get cross-contamination between categories and terms and things like this. And so I really think that this part strategy is paying dividends. So.
No, appreciate that. So as you think about that, if we did a post-mortem here, although we're not done, but what would we do differently next time? Like if you said, oh, I'm going to be faced with a similar challenge in the future, what did you learn? What did we learn from this process?
Let's see. Perhaps I think thinking about the technical setup and challenges first. I think we've actually done a pretty good job of, for example, setting up all the new network and VPN, but to some extent, those were a little bit of a distraction as we're trying to develop the actual technology and code. So but that it is what it is. I don't think it's held us back. yeah, no major regrets so far. So knock on wood.
Anything for you, Kahlil?
I'd say with an unlimited budget, doing it again, I would definitely outsource a lot of the data generation. You've probably heard that data is the new oil. That was a very hot phrase a couple of years back, but it's true. I mean, all machine learning projects live and die by the quality of their data. And even with, these sparkly new, industry leading models like ChatGPT, there were still thousands and thousands of man hours put into tuning it, and that people tuning it, not just, three guys with fancy hats sitting at a computer, telling the computer right from wrong. It was literally people sitting down, taking a look at examples, tweaking the examples, and generating good data. And given a head start on a project like this, that would be probably the first place where I'd place priority is making sure there's an abundance of data like that. Conceivably getting a team of people to go through the entire product catalog and just tagging the parts of speech that we deem important, and that can just immediately feed into an NER architecture.
No, and look, so that is a perfect world, and I think that's probably how people outside of the innovation team would work. I think the challenge becomes that our team, our whole mission is to work very fast. I mean, the proof of concept for this tool was maximum 2 weeks. That was lightning fast. That is way faster than we ever want to go. But in 2 weeks, we were able to show it to the company's CIO, and he's like, how fast can you productionize that, right? So then it became like, okay, now how fast can we do this next thing? It can be hard to work in that environment, but also it can be a lot of fun. But you then learn these lessons where it's like, oh, we should have these VPCs, et cetera, set up. But now we're working toward getting a lot of that in place. We learn those lessons so that as we go down the road, some of these things won't slow us down. But yeah, some of it is always just going to be a function of how fast can we do something.
Yeah, and it's also, I think, to your point, it's I think part of your group's purpose, Wally, and certainly part of our firm's purpose is to work in an imperfect world and get practical results, right? And so it's one thing to go to school and get a nice data set, in Excel or Python or CSV or whatever it is, and then download neural net or random forest model and run it, and you will get something out of there. But it's a completely different thing to be in the real world with all kinds of messy data, processes, politics sometimes. And so that's it's a completely different thing to navigate all those things. And I think that's what I think both of our firms are really good at. And that's why we were able to get something up quick and while still maintaining a decent level of quality, good level of quality.
Yeah. So let's move on. One of the things that I wanted to do in Tech Talk Discuss was to shine light on, are we doing a good job in our Tech Talk simplified and explained videos? I think it's super important to get feedback. I think it's great to learn when you're right, but more important to learn when you're wrong. I had asked for you guys, gave you a little homework and said, hey, look, at least watch one of the 2 videos I put together on NLP. And then we're going to have 3 questions. What did we get right, or at least mostly right? What did I get wrong? And what didn't get mentioned that should have? So let's start with, what did we get right on the video?
Well, I watched the second one, and first of all, I think you're a very natural content creator. So right at home on YouTube or Instagram or TikTok, maybe. But I think it was, most of it was just absolutely right and spot on. I actually liked in the NLP section how you went over some of the techniques, like even regex, which is, if you open an NLP book, that might get a sentence or two because it's not super, new or sexy, I guess, but it's extremely important. I would say even before you feed a neural net or whatever, there are a plethora of things you need to do, like spell check and like lemmatization and like fixing contractions and fractions, looking at stop words, all those things which we did for PoST, by the way. And so I think those are definitely part of the process. So I think I was really happy to see you kind of cover some of those.
So then let's skip that though. Let Kahlil, what did it get wrong? Let's go there.
Wally, you did everything perfectly.
Oh, well, look, I love that. Thank you so much.
This is where Wally says, I know. I'm just kidding.
Yeah.
No, I really don't think you said anything technically wrong, especially like when talking at a super high level. I know you did go into some technical detail, but I'd say the one thing that I think would benefit that kind of format in that video is, if you mentioned lemmatization and tokenization, it would be great for somebody non-technical to see how those parts fit together and how you form a pipeline, right? Because you can throw all these techniques at people and they're like, okay, yeah, tokenization splits up sentences. Lemmatization, gets rid of contractions and stuff like that. That's all great. But why, So, and like also like showing an example sentence. Yep.
And my goal to keep everything very high level. And here I missed the point of then also teaching people how they could connect them. But who says we can't do that in a future video, right? But so as you think about the content, what didn't I mention that you wish I would have?
There are a lot of, I guess when you mentioned, you referred to a set of techniques quite a bit. So that's a super all-encompassing term, which, if you get a book on natural language processing, there'll be a chapter for each of those. it could be worth mentioning some of the things in there and kind of the state of the industry.
I think I'll just go back to what I said previously. I'm a very like learn by example kind of person. Like I can get all the theory, but seeing something in action and maybe like a on-screen animation or even with a whiteboard, taking an input sentence and walking it through the layers of stuff would be good, because I mean, even with super advanced state-of-the-art techniques, they're all just building on top of like basic concepts. And specifically in NLP, they're all very well-known old concepts that come from linguistics. Ultimately, companies like Google, Rasa themselves, they all employ tons of linguistic experts to help make sense of what language is. Because I mean, the English language is horrible, right? There's incongruencies at every corner. So
right. Right. So I made a special point in there that I felt like sentiment analysis is super important. And I'm curious what your thoughts are there, because here's why. I worked in an age where we were reading emails and then trying to just manually determine the sentiment of that and figuring out how we were going to analyze that. And then you would slowly get a little bit more advanced where you're like, oh, let's store all this in an Excel file, right? I mean, like really archaic ways of looking at feedback. So now the fact that it's not as easy, you can't take an off-the-shelf model always. Like you can use sentiment analysis to take stuff that took hours and hours and do it in seconds. So I'm curious if you share that feeling or if you're like, I think you've overblown that part a little.
I personally think, to the extent you mean sentiment analysis in a broader context, that's absolutely true. So if you were to include something like intent analysis, absolutely. I think when you say sentiment, technical people like Kahlil and I are going to think of what the sentiment models that are out there right now, which are A, as we discussed before, not that great, and B, spit out a number from -1 to 1, which is bad or good, or 0 to 1 or whatever it is. And they're not bad. And let's forgetting the fact even for a second that they're bad or good. Let's say that they were perfect. At the end of the day, it's still, it might map, a number to an email or a review or something like that. So if you think about a sales decision, right, it could be very important there. What is, when I'm on the phone with this person, what is the likelihood that they're going to buy my product, right? So that I think still, I've seen the models that currently do that. They're not super good. They're okay at sentiment, but the intent is still escaping them a little bit, at least from what I've seen. And so I think as computers get better, as they mix sentiment and intent, I think that could be very powerful.
And so you talk about that. One of the things that I noted in another video I did was we're going to be using Rasa as part of our chatbot experience, and its ability to understand the intent of, if someone says, do you have water heaters? Do you sell water heaters? I want to buy a water heater. The intent is really the same, but it's have, sell, and buy, which really could mean a lot of different things. Okay, so before we wrap up today, and again, we really appreciate your time, we can't leave without a couple questions about the future, what's ahead of us. And so I'm going to turn it over to David to close this out.
Yeah, sure. And thank you guys again for jumping in. This has been super, super valuable information. And just a couple of questions. And Rob, I'm going to kick this first one to you, and Kahlil, feel free to jump in. And then I've got one directly for you, Kahlil, as well. But Rob, for you, who's been in the industry a long time, you own Austin AI. If you were to say meet a student today who's considering a job in technology, what's the one degree or skill set that you would really encourage them to focus on and develop as they grow and desire to be in this field?
Yeah, so I actually get asked that question by people not infrequently. And what I usually say is, if you can be technical while also having some business chops, that is an amazing combination, because that is, I have a great employee named Kahlil who is like that, and it's very, very rare to find. So, and by technical, I mean actually technical, like coding, or at the very least able to understand code. And by business, I mean, communication and being, I don't necessarily mean going to an MBA or something, but having some kind of chops in the business world. So for example, I think I know a number of people who have had dual degrees of computer science and finance. I think that something like that's incredibly powerful. And maybe it's not computer science, it's engineering, and maybe it's not finance, it's marketing or something business related. But I think, yeah, that's what I tell people when they ask me.
Great feedback. Kahlil, you had your ego stroked there just a little bit. But question coming your way, Kahlil. What's the next thing in your mind in artificial intelligence technology that we should all be trying to leverage from your perspective?
That's a great question. I think there's so much out there right now. Every single company, that kind of is forward thinking has at least somebody doing something with regards to AI. I'll answer this question in a slightly different way. Like, what am I excited to see with AI? Obviously, I'm not an AI researcher, so I'm not out there in the sticks reading, publications that come out, thousands of them. There's even AI models trained to tell you, hey, this is a good paper, you should read this, ignore all these. So the research is really overwhelming, and it's more than a full-time job keeping up with it. But my hope is that AI as it is, even looking back 2 years, is such an amazing tool for not necessarily automation, but just the way that it can help people, and specifically people that have disabilities, right? Like in the vein of NLP, there's also NLG, natural language generation. There was a company that set out to take recordings of people's voices who had ALS, and later stages of ALS, you lose your ability to speak. And they would take these recordings and allow these people to speak to their families by, inputting some text, and it would be a model that generates audio that sounds like that person's original voice. Stuff like that, because I think it's very focused on industry and very, very like, how can we make a buck? The overarching goal should always be like, how can we help as many people as we can? Which I know maybe might not always be the most business savvy thing to say, but that's overall like what I'm excited to see AI do. And I think that there are some great companies that are already doing stuff like that. Something that doesn't get talked about often is models that can actually recognize bias in pre-existing models, because that's a big issue. There's a great book by Kathy O'Neill, and I forget the exact title of the book, but it was something catchy. But this whole book just kind of illustrates how current AI models are biased in ways that hurt people. And ever since that book came out, I was always cognizant of, like, as machine learning researchers, and we're always just looking for having good scores and good accuracy for models to present that to stakeholders and say, hey, we did a good job. In doing a good job, is there also some minority of use cases where we're actually causing harm, and how do we prevent that?
That's it for Tech Talk Discussed, NLP edition. Thanks so much to Rob Corwin and Kahlil Wehmeyer of Austin Artificial Intelligence for joining us today. Really appreciate your time. Hope you're able to leave today's discussion understanding a little bit more about NLP. Thanks for joining. We'll see you next time.